so the next question is, what is the effect of the mixture on the solvent? So if we imagine that distilled water, the stuff that we've got in this beaker here, is reasonably pure water, and we take that as our benchmark, as our control, if you like. What I've got here are two different ice cubes. I tried to pick the similar size ones that I've got. Let's put the clock on, and let's just leave those at room temperature for a period of time. But the one on the right hand side is just going to be distilled water, and the one on the left hand side, I'm going to just pour some sodium chloride solid over that, and we'll leave that going and revisit that in a few minutes time. So that's just doing its thing. I've also got in these two beakers, in the right hand side one some distilled water, and in the left hand side something called saturated sodium chloride solution. Now a saturated solution is a solution where no more of the solute will dissolve at that particular temperature. So because this is saturated at room temperature, if I try to add some more salt to that, like I did in the measuring cylinder, it just won't dissolve because no more can dissolve at this temperature. If we heat it up a bit, more probably could dissolve because the solubility increases, but we'll just stick with the saturated at room temperature one for now, because we know that that's got a reasonably high concentration of the sodium chloride. So there's quite a lot of the sodium chloride dissolved in a particular volume. And what I like to do is see what happens when I heat up both the distilled water and the saturated sodium chloride. See what maximum temperature I can get on this thermometer. Let's have a guess. So I'm going to put these two Bunsen burners onto roaring blue flames, just put them underneath. And that's going to just take a little while to do its thing. Okay, so this has been working for a little while now, just over 13 minutes, and hopefully you can see that the ice cube without the salt on it is still pretty much intact. A little bit of melting, as you might expect with it standing there for so long, whereas the one that we added to the sodium chloride to a little bit earlier has got loads and loads of water on it, just like that. It's melted hugely. So have a think about what that means about the impact that sodium chloride had on the freezing point of this water. If we look over here to these two beakers, this one's just about getting to the stage of boiling. At the minute it's about 97 degrees C on this thermometer. It's just continuing to rise slightly. The expected value for that, of course, have a think. Hopefully you got to the idea of 100 degrees C for water, and that should boil within a really narrow range, so it's nearly there and it's nearly boiling. If you look at this one, this has been bubbling away for quite a while now, and the temperature on the thermometer up here is already at 102 degrees C, and that's stayed nice and stable. So consider what this means about the idea of the presence of salt and the impact that that had on the boiling point of the water. So what you need to consider is the impact of impurities, in this case salt, on the boiling points of substances and the freezing points, or indeed melting points, of substances.